Yesterday we talked about law of sines as a way of solving triangles. But what we noticed pretty quickly is that the law of sines didn't cover every situation. Specifically, it didn't cover if we had a side angle side situation or a side 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 situation. Law of sines didn't work for us. So in that case, we have law of cosines. Now, if we have just all three angles, nothing's going to work. Why is nothing going to work if we have all three angles? Why is that going to be useless for us? Because yeah, it could be any triangle, right? I mean, it could be bigger, smaller. There's no way we can solve the sides because we have to have some sense of scale for the sides. Angle, angle, angle is similarity for triangles, not congruence, and so we need to have something that has all the parts there. So we have to do that. So law of cosines is going to be our vehicle for this. Now, like I said yesterday, law of cosines is not, and law of sines are not huge, huge topics on our chapter test. They are going to be on there. They do show up on the ACT, but just like here, you are not going to have the formulas memorized. You'll be given the formula if you need it. You just need to be able to use it and understand it. Today's stuff is going to be, yesterday was a lot of cross multiplying and solving, which we've done a lot of practice with in our similarity chapter, so that was nothing new. Today is going to be even more algebra involved. Sometimes it's going to be fairly straightforward. Sometimes it's going to be a little bit more work. Every law of cosines problem that we're solving a triangle starts with the law of cosines, but then we switch back to law of sines. So it's going to be a little bit complicated. There's going to be a lot going on here. But again, this is not the major focus of your test coming up on Friday. Major focus of your test tends to be SOHCAHTOA and special triangles like 45, 45, 90, and 30, 60, 90, which SOHCAHTOA you guys did fantastic with. Special triangles, not so much. So we will spend a lot of time tomorrow and probably again on Thursday focused on those 45, 45, 90 triangles and the 30, 60, 90 and the similar right triangles, because that's where people struggled. That's the quiz you struggled on, not the SOHCAHTOA one. So, by the way, if you missed the SOHCAHTOA quiz, make sure that you are getting in there and getting that taken. It's in the test center for you. I don't think anyone failed it, so I don't think anyone's retaking it for that purpose, but yeah. Here's some notes for today. Again, less detailed than yesterday because I'm here today. The other thing I want to point out is, for a lot of you, you started taking notes when we started doing the SOHCAHTOA stuff. And I know you said, well, but that's, and I've heard people say, yeah, well, we did really well in that test because it was easy. Well, could it be that it was easier because you're actually like paying attention and taking notes sometimes? Maybe that have some relationship to why it got a little easier for some people? I mean, as a stats teacher, I can tell you that without a controlled experiment, I can't draw that conclusion. It's a correlation, it's not a causation. Okay? But I do think that there is probably an association between people actively engaging in class by taking a few notes here and there and doing better on tests and having things be easier. Of course, it's easier when you understand it. Okay? So I'm not sure I'm going to be able to continue giving outlines and notes every day like I'm doing, like handing out here, just because, like I say, I'm killing a lot of trees when we get into the next chapter, but it's something that you can do. You don't need me to print this stuff out for you. You can have a notebook and take your own notes. And I think some of you are finding it a very effective thing when you're math class. So just be considering that. Also, just understanding the moving ahead, our process. We are going to have, tomorrow I'll be handing out the reviews. If you want the review early, it is already on Schoology. I've uploaded it. So you can get a PDF of that off Schoology if you want. And then, so we'll be handing those out tomorrow, short classes because of career day. Thursday is going to be just a regular review day, and Friday is going to be the chapter test. Next week, we'll all be doing algebra review. Things like factoring and square roots and extracting roots, equations that have x squared in them. We've been doing linear equations all year. We're going to do equations that have x squared in them because we'll need that for our unit on circles, which starts after spring break. Also, grade-wise, we will be cutting off the quarter at spring break, even though technically the quarter still goes a few days after spring break. Anything that happens after spring break will go into fourth quarter. So I'm going to want all retakes done, all things like that, by the time you leave for spring break. So anything you can get done by that time, that's ideal. Yes?
Are we allowed to, are we still in that thing? Like, can you still turn it day one?
Oh, no, that's old now. Yeah, the SOHCAHTOA, that stuff is, it's going to be on the test, but that homework is passed now. So, all right. By the way, not sure if the sub told you yesterday, but the assignments are on Schoology for this section, and she may not have said anything about that. I'm not checking it today. I won't be checking that until Friday, so don't sweat it too much. It's in Big Ideas. Everything's in Big Ideas. I'm sorry, not Schoology, Big Ideas, yeah. Big Ideas. Sorry.
There was like two.
Love, the first one, the law of sines. The one that deals with law of sines. If you did the law of cosines one, you'll have no idea what's going on because they haven't taught that yet. So, it's fine. If something didn't work right, we've got a couple days to get this straightened out. It's not urgent. Let's take a look at law of cosines. Law of cosines looks amazingly complicated. Do not copy down all three versions of it. You only need one. Okay? This is the one I'd copy down if you're going to copy one down into your notes. Yes. C squared equals A squared plus B squared minus 2AB cosine C. That's the one you'll most commonly see written out as law of cosines. Now, that looks really complicated, but it's not. First off, you don't have to memorize it. But secondly, even if you did have to memorize it, if we take away the 2AB cosine C, what do we have? C squared equals A squared plus B squared. It's Pythagorean theorem, isn't it? In fact, if the angle C is 90 degrees, interesting fact, the cosine of 90 is 0. So this whole thing goes away. So when C is a right 90-degree angle, in other words, when it's a right triangle, you just get C squared equals A squared plus B squared. It's actually kind of nifty. So it is Pythagorean theorem, just a fancy version of it, more abstract version. Couple things to notice about this formula is that the first letter and the last letter are always the same, just lower and uppercase. Lowercase, of course, representing a side, uppercase representing an angle. Do remember with these formulas we're dealing with right now, they are case sensitive, kind of like some passwords that you do on your computer. That's case sensitive. You can't substitute a lowercase b for an uppercase b. They mean different things right now. Lowercase b is a side, uppercase b is an angle. Okay? Notice that the two letters that are used here are the same two letters that are used here as well. So the outer letters are the same, the inner letters are the same. Inner letters are all lowercase. The only angle we have is the cosine at the end. We only have one angle involved. So really, we only have 4 variables now to deal with, instead of like with law of sines where we had possibly up to 6. Here we only have 4. We'll know 3 out of those 4 and solve for the 4th. It's pretty straightforward. Okay? Let's take a look at an example. First off, the question is, am I going to use law of sines or law of cosines with these triangles? Now, pretty much everything today is going to be law of cosines, and I think on the test it even says use law of cosines to solve. Pretty sure it says that, so you'll know what to use. and I'll give you the law. You won't have to guess at what it is or remember it. But since this is a side angle side situation, there is no point where I know an angle and the side opposite. I never know the opposite things. I can't use the law of sines to start with. I have to know one pair of opposites in order to use the law of sines. So this is going to be a law of cosine situation. Which version of the law of cosines do I want to use? Well, that is determined a lot by the angle that we know. We know angle B. Then this, by the way, is side A, and this is side C. I do like to label them so they don't get confused. Okay. Since I know angle B, I'm going to start, and B is my unknown side, I'm going to start with that. So B squared equals A squared. A is 11 plus C squared. So B squared equals A squared plus C squared minus 2AC cosine of angle B. I just fill those numbers in. Now this is really handy when it's in this format because I can just plug that directly into my calculator. Okay, when it's all set up like this, where my unknown is all by itself on the one side of the equation, that life is so easy. I simply plug directly in my calculator, 11 squared plus 14 squared minus 2 times 11 times 14 times cosine 34. And I get 61.65. So that side B is 61.65, right? Does that make sense? Would it make sense for that side to be 61, that third side of the triangle? No, that's way too big. The other two sides are 11 and 14. That 61 is not all appropriate. In fact, it should be the short side. Why is 61 not right? Because that is B. What are we solving for? B squared. So B squared is 61.656. 4 dot dot dot. What do I want? I want B. So what do I have to do? Square root that. Yeah. Just square root that number. 7.9. Okay. That wasn't so bad. And that number makes sense. Awesome. Now, how about the two angles that are unknown? We will only use the law of cosines once in any given problem. We'll then switch to law of sines. So now I could find angle A or angle C. It doesn't matter which one would you like to find. A or C. Okay, let's go with A. So, let's law of sines. So sine of A, which is unknown, over side A, which is 11, equals the sine of B, angle B is 34, over side B, which we just found is 7.9. Now, when you do this in big ideas, sometimes they're going to have some different rounding. They'll tell you the 7.9 is correct, but they'll use the actual full value when setting up their law of sines, and they end up with a slightly different angle measurement. If it marks it wrong, don't sweat it too much, okay? On the test, I would give you anything that's close. It's showing your work. That's what is really what's important. So as long as you get that first piece, the second two pieces, you should still, when you're doing your big ideas work, you got to be showing me the assignment. You got to have a piece of paper writing out the actual work you did. I've got to see it because you're not going to do this in your head. But yeah. So again, we cross multiply. So I multiply both sides by 11 here to get rid of this division. So 11 sine 34 divided by 7.9. Sine 34 divided by 7.9 is 0.7786. So sine of A equals 0.7786. That's the sine of A. How am I going to find angle A? If I know the value of sine, what do I use to find the angle? The inverse function, yes. So second function sine of that number and I get 51.1 degrees. So A is 51.1 degrees. And of course, once I know two angles, I just do 180 minus 51.1 minus 34, and my third angle is 94.9. Boom, we're all set, all done. I've solved that entire triangle. Now, that is complicated, but think of the power that you have now to solve triangles with trigonometry. This is not weak stuff. This is very powerful stuff, because not every triangle is a right triangle. We were working with SOHCAHTOA with just right triangles, which is awesome and fun, but not every triangle is a right triangle. This makes life a lot more flexible for us. The danger here is that people want to apply law of sines and law of cosines to right triangles. Don't do it. On the test, when you start seeing right triangles, just use your plain old SOHCAHTOA to do that, okay? Do not try using law of sines and law of cosines for the right triangles. It kind of gets messy. You really want to just use SOHCAHTOA with those, like we did before, and like you were tremendously successful with. Yes? You will only use law of sines and cosines on the last three problems on the test. Last 2 or 3 problems on the test. I'll just be straight up with that. Don't use it before it says use law of sines or use law of cosines. If you're not told to use it, don't. Good enough? So I don't want you to get confused about that. I want you to score well on the test. I don't want you to be confused. Question? Yeah? What? Oh. We use law of cosensing information for side angle side or side side side. That was. And then there are 4 variables we need to have information for 3. Let's do another one. All right. Now it's a side angle side. I know 2 sides in the included angle, so that's going to be law of cosines. Again, you really don't need to memorize that. You'll be told that on the test. So the side we don't know, I'm going to label here. This is side B, this is side C, this is side A. The side I don't know is, again, side B. So I'm going to start with my B squared. If the unknown was side A, then I'd start with A squared. If the unknown side was side C, I'd start with C squared. Equals the other 2 sides, A squared plus C squared. Minus 2 times those 2 sides times cosine of the angle, beginning and end both with B. And we just plug in our numbers. That's 45 squared plus 43 squared minus 2 times 45 times 43 times cosine of B. I'm cosine of 88, sorry. 88, B is 88. And again, when it's set up like this, this is cake. Put it in our calculator. 45 squared plus 43 squared minus 2 times 45 times 43 times cosine of 88. And it gives me like this big, huge number, 3,738. Oh, that's right. I got to square root that. Ooh. At 61.1. Okay. So we got B squared equals, it was 3738.9. And I took the square root to get B. We're getting a lot of algebra practice, which is good. We want that. Okay. Now I want to find one of my other 2 angles, A or C. Any preference?
C.
C. Okay. So sine of C over side C, which is across from that, that's a 43, equals the sine of the angle we know, 88, over the side opposite that, which we now know is 61.1. I can just multiply both sides by 43 to get rid of that denominator. So I get 43 sine 88 equals about 42.97 divided by 61.1. It's 0.7033. So sine of C is 0.7033. Do not, that has to go to 4 decimal places, okay? And then how do we get the angle? Because we know the sine, inverse sine. And if you can, just use the answer button on your calculator to plug that number in so you don't have to type it in. You get a better answer, 44.9 degrees. So angle C is 44.9. And then we can very quickly find 180 minus 88 minus 44.9. We've got A, right? Got our third angle. We've solved everything about that triangle. All the sides and all the angles. Now, it is a little bit trickier when we know all 3 sides, when it's side, side, side. It's just going to be a little bit more algebra when we know all 3 sides, because now it's not the unknown all by itself and just everything on one side of the equation. The unknown is actually going to be out here on this end of the equation, cosine of B, and we're going to have to work with that. When you know all 3 sides, best strategy is to go for the largest angle first. Go for the biggest angle. So in this case, that's B, which means we're going to start with the longest side out here, B. Okay? So 27 squared equals A squared, which is A is 12, plus 20 squared, minus 2 times 12 times 20 times the cosine of its angle B. Okay? Now we got ourselves a little bit more work, because now we're actually going to have to figure out what all these squares are. 27 squared is 729. Is 144 plus 400 minus 2 times 12 times 20 is 480 times cosine of B. Now, I can combine these 2 numbers, but I can't combine all 3 numbers because this is multiplying my variable. So I could combine these 2, but what a lot of people wind up doing is just this. They just do this. I'm going to subtract the 144. So now I have 6,585 equals 400 minus 480 cos B. And then I subtract the 400. So I get 185 equals negative 480 cos B. And I divide by negative 480. Because I have to undo that multiplication. So I get 185 divided by negative 480 divided by negative 480 is negative 0.3854. Okay? Now you're saying, whoa, negative, is that okay? Yeah, actually it's fine. It's negative because B is what type of an angle? It's obtuse, isn't it? And here's a little fun fact. The cosine of an angle that's bigger than 90 but less than 180 is a negative number. You're saying, well, wait a minute, how does that work with opposite adjacent hypotenuse? Aren't all lengths positive? Yes, they are. And this is not SOHCAHTOA. It's not a right triangle anymore, so some of the rules are changing. So we are allowed to have negative values for cosine. and sine, and tangent for that matter. And again, for more information about that, that's where your trig class comes in. But just suffice to say that's fine. If I take my inverse cosine now of that value, I get us 112.7 degrees. Okay, so I take cosine inverse of that value. $112.7 degrees. Okay, great. Now about the other two angles. Well, pick one you want, and what are we going to do? Same thing we did before, law of sines. Which angle do you want, A or C? Doesn't matter. C, okay? So sine of C over 20 equals a sine of 112.7 over 27. Multiply by 20. So 20 sine 112.7 divided by 27 is 0.6833. And sine inverse of that is 43.1 degrees. So C is 43.1, and then 180 minus 43.1 minus 112.7. This angle is 24.2. And I've got all of my angles. Now that's a lot more algebra when the unknown is an angle. But again, half the reason we're doing laws of sines and cosines, number one is exposure because it is on the ACT, but number two, algebra practice. Most of you are taking Algebra 2 next year. We need more algebra practice. We're going to be getting a lot more algebra practice and a lot more equation solving over the fourth quarter. So you got to know your algebra well. Be able to manipulate and solve equations. All right? So, for today, you do have the assignments and big ideas. The good news is, for the law of cosines assignment, I was not thinking very clearly, and I assigned like 15 problems on that. Ignore that. Do the first 5 only. Okay? And then submit after your first 5. Okay? And again, you may be doing everything right, and you may put in 43.1, and for some reason big ideas wants that to be 43.2. I don't know. Just submit what you got and show your work. Okay? Seriously, submit what you got and show your work. If it marks it wrong, but only do the first 5 problems. I'm sorry, is cutting an assignment by 2/3 a problem for anyone? No. You sure? Okay, I mean, I don't want to burden you. No, it was my bad. I assigned way too much, and by the time I went back to change it, it was too late. So, sorry about that, but just the first 5, okay? Everybody got that? So nobody does all 15 and says, oh, I didn't hear you say just the first 5. Everybody understand? All right, let's get to work.